Now we are going to learn how the transistor it acts as a switch. Now we are going to see two cases. There are two cases. By learning these two cases, we can easily understand how transistor it acts as a switch. First, we are going to learn the first case. Initially, in the first case, we have to supply the low voltage as input. The input must be low. Input is low means 0 volt must be given. How input can be given? With the help of pulse wave generator, we are able to supply the 0 voltage. Here, the output of the pulse wave generator to be fed here. The pulse wave generator, it is capable of generating the voltage in two forms. Sometimes the voltage may be very low, that is 0 volt. Sometimes the voltage will be very high. Alternatively, the clear high voltage, low voltage, high voltage, low voltage. The clear alternatively it is able to the clear produce and it is capable of generating a the clear square wave. Here at that instant, the 0 volt is given here. At this instant, which kind of voltage is fed here? 0 volt is given. 0 volt means the input is low. When 0 volt is given here across this, what will happen? That is the thing. When 0 volt is given, the base current will be 0. There won't be any base current. Are you clear? Because low voltage is given, 0 voltage is given. First thing is, since the input voltage is low, Vi is 0, there won't be any base current. That must be learnt. IB must be taken as 0. Are you clear? So no current flows through the RB. And across this base and emitter, this portion acts like a diode, junction diode. This terminal is P, this terminal is N. So this portion can be treated as a, which one? Small junction diode. Look at here, 0 voltage is given. This 0 volt can be taken as negative. Are you clear? This 0 volt can be taken as negative. Usually you know when the diode will function. If P is connected with negative value, negative voltage, what will happen? Clear that diode it won't function. The diode will be in reverse bias. So across this base and emitter, reverse bias is given. Across this base and emitter, reverse bias is given. When reverse bias is given, what will happen? There won't be any flow of current. Are you clear? There is no flow of current in this across this base and emitter. Base current is 0. Base and emitter portion is reverse biased. There is no flow of base current. Clear? Through this terminal. So what will happen now? Because of not flowing this base current, there won't be any flow of collector current from this power supply. Are you clear? When base current increases, collector current also increases. When base current decreases, collector current also decreases. Since the base current is 0, collector current also will be 0. There is no flow of collector current. Are you clear? So IC should be written as 0. There is no flow of IC through RC. Are you clear? There is no collector current. There is no base current. There is no collector current. Automatically, there is no flow of current through the transistor. Are you clear? Emitter current is a sum of base current and collector current. Both the two currents are absent. Base current is also 0. Collector current also 0. There won't be any emitter current. So, IE is also equal to 0 because IE is a sum of which two? IB plus IC. Here both are 0. Therefore, we can say it as emitter current also 0. On the whole, what happens? This portion through the transistor, there is no current flow. Are you clear? That's why I have written no current flows through the transistor. When current is not flowing means how that one will work? I have drawn the equivalent circuit here. This positive terminal is drawn here. The negative terminal of the portion is drawn here. The same RC is drawn here. The transistor part it is drawn like a switch. Are you clear? Here, look at that. The switch is in the kept it in the open condition. Switch is open. Are you clear? Will there be any flow of current? Certainly, the current cannot flow because it is in open condition. So no flow of current through the switch. Switch is open. So the same switch, the clear operation that is seen here. There is no flow of current through the transistor. That can be compared with the function of the switch. Here also current is not flowing. Here also current is not flowing. When current is not flowing, when 0 volt is given as input, there is no flow of current through the transistor. Now the transistor must be clear, taken as transistor is in cutoff region. Are you clear? Cutoff region means there is no flow of current through this. Since IB is very low, 0, the transistor must be taken as it should be in cutoff region. I have written one formula also. VCC is equal to IC RC plus VCE. Already we have learned the same formula. Here the collector current is 0. Through RC collector current is not flowing. There won't be any potential drop across RC. Are you clear? So look at the formula VCC. VCC is a sum of IC into RC plus VCE. That is the formula. Are you clear? Already we have learned the same formula in various contexts. VCC is equal to IC into RC plus voltage across VCE. That voltage across VCE is nothing but output, Vout. Vout is nothing but voltage across VCE. Are you clear? So look at here, look at the formula. Which one is 0 here? Through the collector, current is 0. Therefore, IC can be written as 0. So what is the remaining thing? The entire VCC, the power supply, its voltage will be equal to which one? VCE. Are you clear? The voltage, what is here, that one will appear here, that can be measured here. For example, if it is 10 volt means, if you keep the voltmeter here, you can measure 10 volt. Are you clear? The potential drop is 0 here because IC is 0. So the same 10 volt, that one will appear here across VCE. The same 10 volt, that one will appear here as output. So V out is nothing but voltage across VCE. That's why I have written VCC is equal to VCE. That is nothing but V out. So you will get high output. Across this two, you will get the output will be high. The same VCC voltage will appear across these two terminals. But current is not flowing. The voltage of the power supply, that one will appear here as output, but no current flows through this. So it shows that the transistor, it is in the off state. The transistor, it is not conducting, no. Therefore, it is said to be in the off state. Understood? Now we are going to see what will happen if the input is high in the case of transistor acts as a switch. Look at here, a pulse type wave is fed into the input. Okay. In the case of pulse type wave, this portion to be assumed as high voltage. Let us say 5 volt. This is low, this one is high. When 5 volt is fed, when high input is fed, that must be considered as positive. Are you clear? As I have told earlier, across base and emitter, this portion can be assumed like a, which one? PN junction diode. Here P is there, here N is there. This small portion, junction portion can be compared with a diode. Look at here, the P is connected with positive and N is connected with the ground. So it shows that this portion is forward biased. Since it is forward biased, what will happen? The base current, it starts flowing. Are you clear? The base current through the RB, it starts flowing. That paves path to the flow of which one? Collector current. When base current increases, the collector current also increases. Are you clear? That is a very important one. When base current increases, collector current also increases. So because of the flow of base current alone, collector current, it starts flowing. So this is the path of the which one? Collector current. So through the transistor, collector current also flows. Base current also is clear, passing through the which one? Transistor. Since both base current as well as collector current both are flowing, what will happen? These two, if both are summed up, that one will appear in the form of which one? Emitter current. Because emitter current is a sum of base current and collector current. So on the whole, the transistor, it conducts. The transistor, it conducts the current. Are you clear? Through the transistor, current is flowing. When current flows through the transistor, maximum amount of collector current flows from the VCC. That collector current flows through the RC and there will be a potential drop. Across RC, you will get a potential drop. Are you clear? So you know what is VCC. The voltage across the power supply is called VCC. Now we will see the formula. Already I have told, when base current increases, collector current also increases. Maximum collector current will flow through the transistor. Transistor, it conducts now. Now we know very well that voltage across RC will also be maximum because IC is maximum. Therefore, voltage across RC will also be maximum. The voltage across VCC, that one will appear here. Are you clear? For example, if it is 10 volt battery means the same 10 volt exactly that can be measured across which one? RC. That you have to understand. So here the thing is, the basic fundamental formula is VCC is a sum of IC into RC. What is IC into RC? Potential drop across RC is called IC into RC. VCC is equal to IC into RC plus VCE. What is VCE? So clear, voltage across collector and emitter is called VCE. Voltage across, that is potential difference across collector and emitter is called, what is this? VCE. Are you clear? That VCE alone is taken as output. The voltage across VCE is called output. Are you clear? Therefore, VCE and Vout both are same. That's why I have drawn the arrowhead. Are you clear? So here what will happen? If you measure the output voltage here, that one will appear as 0 volt. Is it clear? There won't be any potential difference across VCE. So the potential difference VCE is 0. Therefore, if VCE is 0 means output voltage also will be 0. Are you clear? So it shows that most of the current is flowing through the, which one? The transistor. Basically here across this there won't be any potential difference. So in the next step what I have written, VCE is 0, Vout is also 0. That's why I have written 0. So you compare this two, Vout and 0. Finally you are getting that Vout, which is nothing but VCE, that one is 0 volt. So here it shows that transistor it conducts. Transistor it is in the on state. Transistor it is switched on. Through the transistor current flows. But output voltage is 0. Therefore, the transistor it acts like a closed switch. Transistor it acts like a closed switch. Nearby I have drawn one simple diagram. Here I have used this ordinary switch. Clear, look at the function of the ordinary switch. This function of the ordinary switch that can be compared with the transistor. Here also current flows through the transistor. This transistor part alone to be compared with a switch. Look at here, one positive plus VCC terminal is here, negative VCC terminal is here. Clear, both the two, in between these two, one resistance is connected and then one switch is also connected. When the switch it is in the closed state, what will happen? The current will flow from plus VCC and also through the RC. Are you clear? Through the RC, and it also passes through the switch. Since the switch is closed, through the switch current flows. Are you clear? If the voltage is 10 volt means the same 10 volt will appear across this resistance. So the entire voltage in between plus VCC and minus VCC, if it is 10 volt means the same 10 volt will appear here because through the switch current flows. Like this, through the transistor current is conducted, current is passing. Since transistor conducts current, there won't be any output voltage here. Are you clear? Now the transistor should be taken as that is in the on state, that is acting as a closed switch. So this is the function of the transistor when the input is given as high voltage. Are you clear? The input voltage must be given with the help of pulse wave generator. Pulse wave generator, it is capable of generating both low and high voltage alternatively. That one is fed in the form of pulse. Sometimes clear 0 volt, 5 volt, 0 volt, 5 volt, low volt, high volt, low volt, high volt. Alternatively, the input voltage will vary. According to the nature of the input voltage, the output voltage can be obtained. If it is low, clear, across this the voltage will be very high. If it is high, Is it clear? Across this, the voltage will be 0. If it is low, what will happen? Transistor, it won't conduct current. If it is high, transistor will conduct current. You have to understand the concept very thoroughly. Again, I will repeat. If the voltage is low, transistor, it won't conduct current, but output voltage will appear as high. If the input is high, what will happen? Transistor, it conducts current. Output voltage will be 0. Are you clear? So like that, the function of the transistor, it acts as a switch. Okay, thank you.